In this tutorial, we are going to talk about sample size and sample strategies. In most studies, it's difficult to obtain information from the entire population. We rely on samples to make estimates or inferences related to the population. A population in statistics includes all members of a defined group, while a sample is a portion of the population. We take sample to estimate population's values. But the question is, how much data do we need in our sample? There are four factors that determine the size of a sample: the data type, the confidence level, the margin of error for the sample, and the variation in the process or population. I'm going to explain them with this example. Suppose that we want to know what proportion of students in a given school support the death penalty. The data type is discrete because we are looking at the number of students that support the death penalty and the number of students that do not support the death penalty. The confidence level is about how sure we want to be that we could get the same results if we did the study multiple times. If we want it to be 100% sure, then we will need to collect all the data from the entire population. Most researchers use a 95% confidence level. 95% means that we can be 95% sure that we will get the same result if we repeat the test multiple times. The margin of error for the sample is about how accurate we want to be at estimating the population parameter. The margin of error is linked with the confidence level. It represents an interval that has a 95% chance of containing the true population value. For example, if we specify a confidence level of 95% and a margin of error of plus or minus 4%, and the result of our study determines that 30% of the students support the death penalty, it means that we have 95% chance that the true population of students that support the death penalty falls between 26% and 34%. In regards to point 4, variation in the process of population, it's about how is the population distributed in the variable of interest. If, for example, we know from historical data that 20% of the students support the death penalty, then the variation in the process will be 20%. But if we do not have this information, then we will assume a 50%. So let's see how to select the sample size in Minitab. We go to Start, Power and Sample Size for estimation. We want to know the proportion of students that support the death penalty, so it's a discrete data, and we choose proportion binomial. Then we want a confidence level of 95%. We click on options and we have already 95% that is entered, so we click OK. Then we need to enter the margin of error for the sample, and we said that we want to be sure that with a 95% confidence the mean population will be within 4%, so we type 0.04, while for the variation in the population we don't know based on historical data what's the proportion of students that is supporting the death penalty. Then we assume a 50%. Then we type 0.5. When we click OK, the recommended sample size is 623 at 95% confidence level and within a margin of error of 0.04. Now, let's see another example with continuous data. We need to estimate the average turnaround time to complete a transaction in a bank. From historical data, we know that typical turnaround time is from 30 minutes to 2 hours, and the standard deviation is 40 minutes. What sample size do we need if we want to be 95% confident that the sample mean is within plus or minus 3 minutes of the population mean? Okay, so to select the sample size, we go to Stat, Power and Sample Size for estimation. This is continuous data. Then we select mean normal. We want to be 95% sure as a confidence level, so the confidence level is 95%. The margin of error will be within plus or minus 3 minutes of the population mean, so we type 3, and the standard deviation is 40 minutes, so we type 40. If we go again into options, we assume that the population standard deviation is known, so we tick this button. When we click OK, the recommended sample size is 683. Let's talk now about the sampling strategy to select samples. There are 4 different types of sampling strategies. Let's see each of them. The first type is the random sampling. In a random sample, every member in the population has an equal chance of being selected. The second type is the stratified random sampling. A stratified random sample is subdividing a population into distinct groups based on a segment, and then taking a proportionate random sample from each group. The third type is the systematic sampling. Suppose you want to sample 15 houses from a street of 60 houses. Then we divide 60 by the sample 15, which means that every fourth house is chosen after a random starting point. The fourth type is the rational subgrouping. The rational subgrouping is a sampling strategy for process studies. It's usually used to collect data for statistical process control and control charts. An example of rational subgrouping is to take samples at various times of day, and we choose to take 2 observations every hour. Collecting this data helps us to identify 2 sources of variation: variation within the hour and variation across the hours.